Okay, so this is problem 7 on your homework. We've talked about this problem in class, so we're going to go ahead and work it out now. Well, here we go. A student drove to the university from her home and noted the odometer reading of her car increased by 12 kilometers. So the odometer, that tells you basically the distance that you've driven as opposed to your displacement, right? Example, if you drove 4 kilometers this way, and then you took a right turn and drove 3 kilometers in this direction, and so here is your home, and here is the university. Then the distance that you have driven distance is in the common sense understanding of distance. You drove 4 kilometers and then 3 kilometers, so 7 kilometers. However, your displacement, that's different. Displacement, remember, we're trying to distinguish those two guys. Your displacement, that is the distance between where you stopped and where you started. So your displacement is this distance right here, okay? That's not 7 kilometers. It is, according to the Pythagorean theorem, a squared plus b squared equals c squared. That's 5 kilometers. Okay, so keep that in mind here, because when they ask for speed, average speed, that's distance over time. That is different from velocity. Velocity, that's displacement over time. You got to remember that difference. Right? So velocity, we'll use a different color here, green. Okay, I really can write, okay, but right now I'm trying to write like at a weird 45-degree angle with my hand to the tablet. Displace, I know I should just put it on the table like a piece of paper, but no, I'm sitting on my couch trying to write this thing, do this problem, sitting upright, and yeah, it's crazy. Displacement over time. Okay, so that's different from your average speed. Speed is just distance over time. Velocity is displacement over time. So keep that in mind when you're doing these problems. All right, so then let's proceed with this problem. So here, you drove. So your odometer on your car, that tells you the distance, okay? So yeah, so that 12 kilometers, odometer reading, that's the distance. Okay, and they tell you how long it took, 19.3 minutes, all right? So you want to know your speed, right? So speed is, as we just said, distance over time. Okay, so for those of you that have been kind of paying attention a little bit in class, we've really been talking about these graphs and how to represent motion using a graph. We've talked specifically about 2 different kinds of graphs today, and there are several apps on our physics page you really should look at and play around with. Okay, so specifically, there is like displacement, or delta x over t. And the thing is, if you look at this graph right here, okay, there's this thing called slope, right? Slope, rise over run. Usually it's a delta y over delta t if it's an x versus y graph or y versus x graph. But here it's x versus t, but it's always rise over run. And I know you've seen this before because this is taught in IM1, all right, which you've all taken. So rise over run, well, the rise, that's the vertical part of this, that's delta x. And the run, that's the horizontal part of this, that is delta t. So the slope is rise over run, that's delta x over delta t. But guess what? That is the definition of speed, all right? So on a x versus t graph, distance versus time, the slope is the velocity, right? V is the velocity. V is x over t, or V average, I should say. And this is really important because a lot of what we're going to be doing and learning about this year can be represented with graphs, right? It's a picture way of understanding a physical situation in the universe, because it is true that a picture is worth 1,000 words, probably more than 1,000 words. These pictures are universal and they're very, very powerful in explaining concepts, which is another reason I tell you, when you're doing these problems, draw a picture. You don't have to be a tremendously talented artist. Draw a picture, like little stick people, okay, like I do. Pictures help a whole lot in formulating and understanding these concepts, which are very, very abstract concepts, right? So, anyway, enough of that. Speed is distance over time. So in this problem, well, okay, so that's easy. The distance was 12 kilometers. And the time was 19.3 minutes. So this is interesting because you probably maybe could enter 12 divided by 19. But if you do that, the units need to be kilometers per minute, right? So let's just see, what is this in kilometers per minute? So you get your calculator out, right? Calculator. And you do 12. And then you do 19.3 and you divide those. And that gives you 0.62. And I might try this, I haven't before, but the units here are going to be kilometers per minute. And this program, right, this Physics LE program, I believe it is probably smart enough that if you put in these units, it'll count this answer as correct. Notice here, though, I went ahead and I've converted kilometers into meters, and I've converted minutes into seconds, and that ends up being 10.4 meters per second, because usually when we are using speeds or velocities, it's in meters per second typically. So to get the answer in meters per second, here's what we did. We've done this in class before, but let's go ahead and work it out again here. But I'm thinking you could probably, if you enter in, like I said, you just do 12 divided by 19.3 and then put in the correct units, it'll probably still count that correct. Maybe. We'll have to find out. So then, to get the answer in meters per second, here's what we did. You have to change, well, let me just write this stuff out here. So again, V average is equal to delta x over delta t. So your delta x is 12 kilometers, and your delta t is 19.3 minutes. And this is also why you must attach units to the numbers. Numbers without units attached to them are pretty meaningless. So that is going to be equal to, well, we want to convert this, right? So here we go, converting. We've talked about this too. It's factor label, right? To convert this into meters per second, you need to change kilometers into meters. and you need to change minutes into seconds. All right, so you multiply that by a string of factors. This is called factor label, okay? So you want the dimensions, or you want the units of kilometers, for example, to cancel. All right, so let's do this. Let's make this kilometers in green. Kilometers, all right? Oh, okay, there was a glitch in the matrix. Oh, so we want kilometers to cancel out. That means I need to put kilometers down here, and up here I want there to be meters. But now you have to have the correct units in place. So question mark over question mark. How many meters are in a kilometer? Or how many kilometers are in a meter? Well, there's 1,000 meters in 1 kilometer. So that means that kilometers are going to cancel. The dimensions. So that upstairs I just have 12 times 1,000 meters. All right. Then we also need to change minutes into seconds. So let's use blue for that, all right? So multiply by another factor here. And that's going to be in 1 minute, there are 60 seconds. All right, so when I do that, check it out. Dimensionally, minutes cancel minutes, and the dimensions I have left over in the problem are meters over seconds, right? So now let's do the math. So upstairs it's 12 times 1,000, so that's 12,000 meters divided by the bottom part. I'm going to do 19.3 times 60, and that is 1,158 seconds. So now let's divide those two guys and see what we get. I get 10.36. Meters per second. However, this program also requires that you use the correct number of significant figures, okay? And either it'll tell you what that number is, or you determine that by reading the question. So up here, check it out. There's 12 kilometers. How many digits are in that? Well, there's a 1, and there's a 2, and there is a 0. That's 3 digits. Let's look at the next number. Check it out. There's a 1, there's a 9, and there's a 3. 3 digits, 3 figures. So the question requires that the answer have the same number of figures, which is 3. Yikes, but look at that. 10.36, that's too many. I have 4 digits there. No problem. You round it to 3. So if this guy right here is a 5 or greater, that means you bump the 3 up to 4, giving you 10.4. And then you push, check your answer, and you get that little green check mark, and oh man, it's such a good feeling. Yay, you got the problem right. All right, anyway, okay, so that's good for this particular problem. We did all of this in class today, which may be yesterday by the time you're viewing this, or maybe a week ago by the time you're viewing this. In any case, I'll finish doing the rest of this problem at a future date, okay? So, have a good night, guys.